Okay, so this is our section 1 of the Algebra Midterm Review, solving linear equations and inequalities. So this is mainly where we're going to be solving for x, or a variable. So for number 1, we're solving for x and graphing the inequality on the number line below. So right now we have 2x plus 7 is greater than 15. Right now, again, our goal is to get x all by itself. Right now it's not. It has a 2 next to it, and it has this plus 7 next to it. So what I'm going to do is I'm going to subtract this 7, use our inverse operations to start our steps of getting our variable by itself. So I'm going to subtract 7 from either side of this inequality side here. So I'm going to erase that and keep on. So positive 7 minus 7, that's going to cancel out. So we're going to be left with 2x on the left side, greater than. Then 15 minus 7 is going to be 8. We're still not done. We still have a 2 next to the x, and that's 2 times x. So we're going to divide both sides by 2 to get x by itself. 2 divided by 2, that cancels out to a 1. 8 divided by 2, that is a 4. I'm going to move our answer up here. So we're going to have an x is greater than 4. So the other half of our problem is to graph our inequality. So whenever it is a greater than or less than symbol, so the two that I'm drawing right now, those are an open circle. So I'm going to draw an open circle on this number line. I'm going to do a 4. You do not have to fill out every single tick mark on this line. You can just do one above. So I'm going to put 5, and one below, put 3. So 3, 4, 5, and since this is x is greater than 4, meaning all of our answers can be any number larger than 4, which means our arrow is going to point to the right. Also notice that our little inequality symbol, it's also kind of pointing towards the right side. So that's a trick you can use. But that only works if our variable, so our x, is on the left. But that's just a helpful hint. So let's move on to number 2. Solve for y this time and graph the inequality. So same question, except this time, now we have variables on both sides of our inequality symbol. And the inequality looks a little bit different. So this one is a less than symbol. And when we have a less than or equal to symbol, less than or equal to or greater than or equal to have an closed in circle for graphing. So what our goal is we want to get y on one side of the inequality and our constants, which is -2 and 24, on the other side. So I'm going to start by moving my variables. So I want this minus 8y on the left side. In order for me to do that, I need to do the opposite to it. Right now, instead of minus 8y, I'm going to do plus 8y to either side of our inequality sign. So that is very important. All right, you only do it once on either side. Think of it like a seesaw where you want it to be completely balanced. So we have to do the same thing to both sides of our inequality. So minus 8y and plus 8y cancel, and then we have this minus 4y plus 8y. So we'll be left with this -2 because we bring that down. And the minus 4y plus 8y is going to give us a plus 4y. And then we have our symbol. And then we have 24. All right. We still have to do a few more steps here because now everything with the y is on the left side, but our two constants are still on either side. So let us move our minus 2, over to the right side. So we're going to add 2 to both sides using inverse operations. So minus 2 plus 2 will cancel out. And then we have 24 plus 2. So let's see. I'm going to move my work over to the right a little bit. So we're going to have 4y is less than or equal to 26. And then our final step before we solve for y, we are going to divide either side of our inequality by 4, which is going to get us y is less than or equal to 6.5. So same thing as before. I am just going to put 6.5 on our number line. And maybe I will put a 7.5 here and 5.5 here. This is a filled in circle. And it's saying that y has to be less than or equal to 6.5. So if it has to be less than 6.5, we want to draw our arrow with the numbers that are smaller than 6.5. So towards the left. All right, and now we're moving on to some distributive property. So 3 is solving for x, but we have 2 in parentheses, x plus 7 equals 14x. So our very first step always, even with the 2 problems beforehand, is to check to see if we need to distribute. And we do in this case. We need to distribute this 2 onto this x and this 2 onto this 7. So 2 times x is 2x plus 2 times 7. I'm going to even break it down like this. Is equal to 14x. Going to bring it down and simplify. 2x plus 14 is equal to 14x. We need to do the same thing as numbers 1 and 2. We need to get our x by itself. Usually, I like to move our variable to the left side of our equation, but this time, our constant, this 14 here that I'm underlining, there is no constant on the right side. So what I'm going to do is I'm going to move our 2x to the right side of the equation. So minus 2x to both sides of this equal sign. Again, it's important that you only do it once, right? We're not subtracting 2x from every single term here. We're only subtracting it one time on the left side and one time on the right side to keep it balanced. So we're going to have 14 is equal to 12x. So our final step, x is still not by itself. We need to do the opposite of 12 times x. So we're going to divide by 12. Our answer is going to be 7 over 6 is equal to x, or you may have also gotten a decimal, but this is the fraction form of what 14 over 12 is, as simplified as can be. So we have x is equal to 7 over 6. All right, moving on to the next one. Number 4, we are solving for u this time, and we have a lot more variables than the last one. We have 3u plus 17 minus 2u plus 5 times u plus 3 equals 0. So our very first step is to always distribute if necessary. So distribute. So 5 times u and 5 times 3. So I'm going to rewrite. We have 3u plus 17 minus 2u plus 5u. Because, right, we have 5 times u plus 5 times 3, right? So plus 5 times 3, which is 15, is equal to 0. All right. Our second step is always going to be combine like terms. And all of this is if necessary. So distribute if necessary, combine like terms if necessary. So I'm going to highlight our 2 different types of terms we have here, because we have some of these terms that have a u and some of these terms don't. So what you'll do is highlight, box, circle anything that has a u. So we have this 3u here. We have this negative 2u. We have a positive 5u. And then I'll switch to a different color and I'll do our constants. We have this 17 and this 15. And it specifically, when we combine like terms, it is on either side of this equal sign. The right side of our equal sign has a 0, so that isn't, there's nothing to combine there since it's already a 0. So what I'm going to do is I'm going to take everything that I have highlighted in green here, and I'm going to just add or subtract across. That depends on the sign. So we have a positive 3u minus 2u plus 5u. So in your calculator or in your head, you can do 3 minus 2 plus 5. So that will end up being 6u. And then 17 plus 15 is going to be plus 32. And then we have this equals 0. And then finally, step 3 is where we isolate our variable. Isolate our variable. So we do this using inverse operations. Right now, 6u plus 32 equals 0. That u is not by itself. So let's do our steps. We're going to subtract 32 from both sides of our equal sign just once. So I'm drawing a little dashed line to make sure we do that just once. And we're going to get 6u is equal to negative 32. And then we're going to divide both sides by 6. So when we divide both sides by 6, we are going to get u is equal to negative 16 over 3. And that is the simplified fraction form. If you got the decimal, that would be 5.3 repeating, negative 5.3 repeating. So it might also be this. Well, not might, it is. Negative 5.3 repeating. Either one of those is the answer to this problem. Okay, so let me move on to our next page here. So 5, solve for x in the formula below. So this one is from our literal equations part of Unit 1, where we basically are doing the same thing as problems 1 through 4, except now we just have all variables. So we still need to follow our steps. Distribute if necessary, combine like terms, which typically in the case of literal equations, what we'll see here is usually simplified. And then our final step is to isolate our variable using inverse operations. So this is solve for x. Our x value is the one right here, and we have a w and z next to it. So when we have a bunch of numbers or variables all next to each other like this, that is typically multiplication. So we're needing to do the opposite of multiplication to get that x by itself. So we're going to divide both sides by wz. Divide both sides of our equal sign by wz, right? Because w divided by w would just be 1, because anything divided by itself is 1, right? Like if I said 5 divided by 5, that's a 1. Z divided by z, also a 1. But since these are all variables, nothing is really going to combine because y, w, and z are all different. So we're going to end up with y over wz is equal to x. And the question was asking us to solve for x, and it looks like we did. X is all by itself. So there we go. All right, number 6, solve for h in terms of y and z. The most important part of number 6 is this part here where it just says solve for h. Right? In terms of y and z, meaning those are the other variables here. So we're going to use inverse operations again. We have h minus z equals y. What's the opposite of minus z? That is plus z to either side of our equal sign, right? Like I'm going to draw little dashes there. Minus z plus z, that cancels out. So we will get h is equal to y plus z. And that's the answer to 6. All right, moving on to our last one in this section, number 7. We have another solve for x. This time we have even more variables. So our first step is always distribute if necessary, which I don't see any parentheses, so looks like we don't have to. And then our second is to combine like terms if necessary. And there's a lot of like terms here. And that's specifically on either side of this equal sign. So I am putting these dashes here to help us out. So I'll start highlighting once again. So everything with x, I'm going to highlight in green. So we have this 2x, this minus 5x, and this minus 7x. I'll also do it on the other side of the equal sign because we have a minus 4x over here and a minus x. And then for our constants, it looks like we have a negative 13, 27, and a 2. So now only on either side of the equal sign do we combine like terms, meaning that this 2x plus 5x minus 7, those are the ones that we will combine together. So 2x plus 5x minus 7x is going to be, let's see, 2x, 5x, that's 7x. Minus 7x is, that's just 0. So that actually cancels out. And then we have this minus 13 that we can bring down. So we really just have a minus 13. And then we have equals. I'm going to erase this a little bit. So we finished combining like terms on the left side of the equal sign. Now on the right side, we have 27 plus 2. So 27 plus 2 is 29. All right, so 27 and 2. And then we have a minus 4x and a minus x. Don't forget that a minus x is the same thing as a minus 1x. So minus 4x minus 1x, that is a minus 5x. All right. So we have just combined like terms. But we still have to solve for x. Right now our x is on the right side. And there's nothing with an x on the left because it all just equaled 0, right? Because 7 minus 7 is just 0. So I say we move that 29 over to the left side to try to get our x by itself. So I'm going to subtract 29 from both sides. 29 minus 29 will cancel out. Negative 13 minus 29 is going to be a negative 42. And that'll be equal to a negative 5x. So we're going to divide both sides by negative 5. So negative 5x divided by negative 5, that's going to cancel out. Negative 42 over negative 5 is going to be 42 divided by 5. 8.4 is equal to x. And that's going to be positive because we have two negatives that cancel. So 8.4 over x. If you want the simplified fraction, like we've been doing for the other ones, the answer would just be 42 over 5 because that doesn't simplify down anymore. So that's it for section 1. And I will also be posting all of the other sections separately.